Hi everyone. Today lesson we're going to look at how to apply first principles to find the derivative of something. Now, the first principle is used to find the derivative, or we can say the gradient of the tangent. Okay, it's just a longer way to do it without, going through a formula. So what is the idea of the first principle? Let me just do it here. Now think about you have a original graph, right? This is f of x. Then think about you have a point here. And let's say this point is x comma f of x. Then you want to find the gradients passing of the tangent that passing this point. So you want to know what is the gradient of this point, which is basically the derivative. Now, the original idea is think about you have a point that very close to this point, but also lie on the line y equal f of x. So think about have a point very close to that, so kind of something like that. So you can see there's a gap between the red point and the black point, and let's call that gap h. So if this is x, then this black one will be x plus h, and assuming h is very, very, very small because the points are very close to each other. Okay, so x plus h is the exponents, and then if you substitute that into here, you get the y, which is f of x plus h. So the gradient passing those 2 points will be y2 minus y1. So f of x plus h minus f of x over x plus h minus x, like that. So x minus x cancel out, so you left with f of x plus h minus f of x over h. Okay, so this represents the gradient passing those 2 points, but we are interested in to find the gradient of the tangent. So the tangent just passing 1 point, and that point is a red point here, just x. So this means that those 2 points must be very, very close. So it must be identical exactly for that to be a tangent, because tangent you can only touch at 1 point. So what that means is the gradient of a tangent is happen when h here is very small, or you can say h approaching 0. That's where we use limit. So limit of h approaching 0. So if h approaching 0, those 2 points are become identical, and you have a tangent there. So of the gradient, which we just found here, f of x plus h minus f of x over h. So this, we call this the first principle. So it helps you finding the gradient of the tangent. Okay. So I'm writing here formula of the first principle would be lim of h approaching 0 of f of x plus h minus f of x over h. So pretty much the step that you do, we're going to do an example here, but you just find in f of x, you find in f of x plus h, and you just sub in the formula, and you just simplify them. Now, let's do this one. So use first principle to find the derivative of this. So we have lim of h approaching 0, f of x plus h is not given to us. F of x have been given. So I just write here f of x plus h, where you substitute letter x with letter x plus h. So you have 3. Instead of writing x squared, you write x plus h squared. Okay, plus 2 x plus h, and then plus 2, like that. And so this one is the whole bunch of thing here. F of x is literally the original equation, 3x squared plus 2x plus 2. Okay, now you can check in the formula and simplify them, or maybe you can just expand this one out first, and you put in later, up to you. But I'm just now I just chuck them all in and then I use and then I simplify later. So I use h of lim of h approaching 0. So f of x plus h is a whole bunch of things here. I want to try again. 3x plus h square plus 2 x plus h plus 2. And then minus, so you have the minus in the middle. And then you do f of x, which is the whole thing here. 3x squared plus 2x plus 2 over h. Okay, now we simplify. So to expand this, you will have to do, so you keep the limit outside, then you do 3x plus h squared x squared plus 2x plus h squared, and then you expand this one now. You have plus 2x plus 2h plus 2, and then minus 3x squared plus 2x plus 2 over h. Okay, then keep simplifying. So you have limit of h approaching 0. Then I expand this one more time. I have 3x squared plus 6xh plus 3h squared plus 2x plus 2h plus 2 minus 3x squared. Maybe keep that in bracket. 3x squared plus 2x plus 2 over h. All right, now we look for like term and simplify. 3x squared minus 3x squared go away. 2x minus 2x also go away. 2 minus 2 go away. Okay, so what you left with is you left with 6xh plus 3h squared plus 2h over h, and you still keep the limit outside. All right. Then h, you can see all of these have h, 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 h. So you can cancel one h out for each term. So h here cancel out, one h on here cancel out, h square become one h, and then one h will go away. So you left with just 6x plus 3h. Okay, limit of h approaching 0. There you go. Once you've done that, sorry, plus 2. Once you've done that, then you can substitute h equals 0 in. So you left with 6x plus, replace at h0, 3 times 0 plus 2. 3 times 0 is 0, so 6x plus 2. That's how we do first principle.